Welcome to Lackwerk Peter's stand here at Productronica. Delighted to be joined by Sven Kramer. Nice to see you, Sven.
Nice to see you, Trevor.
Yeah. So, obviously, it's been 2 years. We've all been locked up, but the companies have been busy. You've been busy too with some really interesting developments around thermal materials.
Right.
Can you tell us a little bit about what you've been doing?
Yeah, we were thinking about the thermal management on printed circuit board assemblies in general, and this is becoming more and more of a topic to dissipate heat away from assembled printed circuit boards. There are different ways of doing that actively, for example with heat pipes or copper coins, which are implemented into the printed circuit board, but this is all very costly, troublesome. So we thought, why don't we make a paste based on epoxy and silicon, two different materials, to have a heat spreader which is applied by the printed circuit board manufacturer. Right. So this is nothing which needs to be done by the EMS or OEM companies. This process is carried out by the printed circuit board manufacturers in a screen printing operation.
So this takes you away from the thermal interface materials such as films or greases or these types of things that they typically use.
Yes.
So you've got an example of one here, for example, if we can hold that up to take a look at. And do you want to indicate the area that's...
This black area, this is the heatsink paste, as we call it,
okay.
HSP. It's basically a one-component epoxy material which is filled with ceramics in order to generate a high level of thermal transfer, heat dissipation of these materials. And the nice thing about these materials is that they are screen defined, so you don't need to cut these thermal interface pads, for example. You just print it with a predefined screen in any shape and thickness.
Okay, because I'm looking at this and it takes up quite a bit of real estate on this sample board here.
Yeah.
But you could do it in any configuration depending on the layout of the board.
Exactly. Yes.
Right. Okay.
So this is one example. This is actually a heat spreader, and if we look at this material, this is different. It's softer. You feel that, not as hard as the epoxy.
Yes.
This is a silicone-based material. And the printed circuit board you see here is from a surgical lamp. So on the other side we have high power LEDs which generate a lot of heat.
Yep.
And on the other side we have this thermal interface paste which is then assembled to the actual heatsink.
Yeah.
And because it's soft, the total contact area to the heatsink is high.
Yeah,
and we have a very good heat dissipation there.
Absolutely, yeah. I mean, it spreads right across the whole surface of the device. Excellent, excellent. What is the thermal conductivity of these materials?
Well, it depends. Generally speaking, I would say in the range of 2 watts per meter Kelvin.
Okay, good. So, obviously, this is something, as you say, is put on by the PCB manufacturer. They already have this type of equipment and capability in-house?
Exactly, yes.
Yeah.
As it is applied by screen printing, this is something which virtually every printed circuit board manufacturer has in-house in order to apply etch resist, solder resist, nomenclature, etc.
Right. And the method of curing is?
Thermally.
Yeah.
So typically that is 150 degrees Celsius for like 45 minutes, and then you're all done.
Right. Okay.
By the way, it's also an electrical insulator. So these both materials, the white one and this black one, are not electrically conductive. They are insulators, and therefore they can be put directly over traces. Right. There is no insulation necessary of solder mask, for example, which would lower the total heat transfer. Actually.
It's a very novel approach, Sven. I really like it.
Thank you.
Thank you for showing us that. What else have you been working on over the last couple of years? What else is trending?
What else is trending in our business on the printed circuit board sides are solder masks, for example, for thermally high applications, 175 degrees Celsius,
Yeah.
for example, where these materials are resistant. Inkjet materials, so fully digital application of solder mask, for example. That is one thing. And on the assembly side of our business, conformal coatings, etc., we have introduced various coatings for UV and moisture cure,
Right.
which offer an outstanding performance in terms of electrical protection against moisture influence, for example.
Right, okay. And I guess finally, in terms of markets, you know, a lot of your business has been driven by automotive and the EV side of
Right.
of things.
This is especially true for the heatsink paste. One of the drivers there, the main drivers, is the automotive industry, electrical vehicles, where this is applied a lot. Converters, for example, DC-DC converters.
Yeah, yeah, excellent. Okay, great. Well, it's great to see you still coming out with great innovations. I mean, of course, Peter's business has been around for a long time.
Yes.
It's a family-owned business, so it's still family-owned, isn't it?
Yeah. Third generation.
Really?
More than 50 years that we are around. And, well, we hope to continue for many, many more years and come with exciting innovations.
Excellent. Great. Well, thank you for sharing that with us today, Sven, and we wish you every success with the new products.
Thank you, Trevor.